Word on this, and so we can get started. All right. So, um, as I mentioned, you have your first lab. So, in case you don't know where the labs are, they're in assignments, labs, and the first lab we're going to be doing together is going to be the cemetery morphy lab. And I say together, as just you're doing it with yourself or your group. As I sort of made mention of, if you do go into this assignment folders, there is a group sign up sheet. So remember, it's just a Google Drive sheet. You guys are section 2. So whenever this decides to load, section 2, it looks like some of you have signed up for group, others have not. I definitely recommend signing up for a group because again, it takes these assignments that are not very difficult and really distills them down into much smaller chunks to do. At least that's my opinion. I know group work is not exactly the most fun thing in the world, but it does make these assignments much easier. If you want to work by yourself or you only want to work in a group of 2, that's okay as well. I don't mind. I usually I have groups of 4 here. Some new people. For instance, like this group of 3. I don't know if you guys know each other or not, but like maybe it's a good idea for someone to hop in there and make 3 new friends. Because again, group work makes it so much easier, and group work is obviously an important part of I was going to say part of science, but you guys aren't scientists. That's a really important part of sort of every sort of career track. So, all right. So the assignment is here. It's our cemetery demography lab. I think you guys will find this one a little bit interesting. Now we're going to talk about the background information on this on Wednesday. I'm sorry, Thursday. Uh, so you don't need to worry too much about sort of the interpretation, but the basic gist of what we're going to be doing at this lab is you're going to be scouring cemetery records, getting some birth and death dates, and constructing what's called a survivorship curve. And we'll talk about survivorship curves again on Thursday, but I want to just sort of introduce you guys to this, what we're doing, and so on and so forth. So you have 2 options for how to do this lab. Now you can if you live near a cemetery or you know of a cemetery near you, you can go to a cemetery and collect your data. Like for instance, I live in Easton, Massachusetts. I know there are 2 cemeteries here in Easton I could go to if I so chose. Ironically enough, the house I bought in Easton, um, I bought it over another house that was actually right in front of a cemetery. So I almost bought a house near a cemetery. So that means nothing to anyone but me. So, anyways, if you don't want to go to a cemetery, or if you say it's not, you don't feel like safe going to a cemetery, or maybe you have a religious reason for not going to a cemetery, that's a-okay as well. But you actually can take advantage of interment. So if you click on this link here, this is the handout, just to show you where I got that handout from. It's labs, cemetery lab, and then there's a handout right here um, in the cemetery lab. This is also where you will turn in your lab as well. So, but we can go interment.net, pop it open, and you'll see it brings us to this website. It's a cemetery records online, which is kind of a handy thing. This is the main site. You don't need to sign up for an account. You don't need to look up records or anything. You don't need to do anything. Just scroll down from the main page and you'll start to see browse cemetery records by region. You also see their specialized collections and some latest edition things like, oh, here's some cemetery records from Texas or Quebec or whatever. Now, the goal of this lab is to understand population, but also for you guys to ask some scientific question. And so you want to ask a question that you find potentially interesting to you. And this question can be broad. Is there a difference in survivorship between the North and the South, between men and women, between Black people and white people, between Asia and North America, between
Professor, your mic just cut out.
So again, decide on a question. It could be simple as, United States versus Australia. That's really easy. North, South, whatever you want to do. So I'm going to hop into the United States records, and you scroll down here in the United States, and you'll see all the states here. I'm going to hop into Massachusetts. And because I'm thinking the easiest sort of question to ask here is there a difference in life expectancy and survivorship between men and women? It's a really easy question to ask, really easy question to answer. So let's try that out. Let's see what that looks like. So what I'm going to do here is actually um, click on Bristol County. That's where I live. And I'm going to scroll down and I'm going to click on this very first cemetery. And you'll notice it'll pop open records for a cemetery of interest. And this is a pretty small cemetery. You can see it's in Oshnett, Massachusetts. So it's relatively close to where I live. And you can see we have a bunch of records for people. So we have these two people that are likely related, the Dixons. It tells us, Marion, it's likely a woman. Let's assume so. And then we have Thomas, likely a man. So they're likely husband and wife. And you'll see we get this information here: birth date, death date. And that's the important information that we want. So what I would recommend doing is, again, once you decide on your question, north versus south, male versus female, black versus white, doesn't really matter. Um, Pop open to a Google sheet. Google Sheets are easier because you can share them between and start to enter this data. So, for instance, we'll start to make a nice little spreadsheet here. I'll have, death date, or let me do birth first, birth, year, death year, and then age, and then category. I think that's right. So this person, for instance, was born in 1910. They died in 1996. Their age would simply be their death year minus their birth year. So this person died at 86, and this was a woman, so I'll just mark her as a female because that's going to be my comparison here. And then I'll go back and grab her husband here, this gentleman. Let's see, he was born in 1909. He died in 1993. That's kind of sad. And he was a male, and let me just drag this down to fill it out for me. So he died 2 years younger than his wife. So that's the sort of data you're getting. When birth year, birth year, death year. You want to know how old the person was when they died. And that's really the backbone of your data. Birth and death for your two distinct categories. Again, it could be male, female, north versus south, Asia versus Europe, whatever it is. You choose based upon your interest. It's really straightforward in terms of data collection. Now, in terms of how much data you need to collect, each person needs to collect 100 data points. I know that sounds like a lot, but as you saw, I did 2 in about 30 seconds, so it doesn't take that long. I know it might seem kind of arduous. It doesn't take super long, so don't feel like this is going to take you forever. But each person in your group needs to collect 100 data points. So if you have a group of 4, for instance, if you had a group of 4, you would need 400 data points. If you had a group of 3, you need 300 data points, 200 for a group of 2, and 100 if you're working by yourself, right? Now, for those data points, you want them split 50-50. So I would want, in this case, if I had 400, I would want 400 males, 200 males and 200 females. So you want them split about 50-50 between the two. So that's your goal, 100 data points, every person in the class should be collecting. So again, if you're gonna work by yourself, if I were to do this, I'd collect 50 males. The recording will show you how to do it, but also this little Excel file that I'm working on will be right here for you to see sort of how you um, how I went about doing what I was doing. So, and there's instructions for you here as well, just to let you know. And there's instructions in the handout that you have to fill out as well. So now the first thing you want to do is basically bin every piece of data you have into 5-year age classes. So you start with age class 0. This will be the people that unfortunately died as infants, right? People that didn't make it to 1 year old. So your age class 0 will be the unfortunate people you find, or the babies, I should say, that did not make it to 1 year old. And it's kind of sad, but it's sort of the reality of it. Then from there, your next age class will be 1 to 5, 6 to 10, 11, 15, so on and so forth. Now, you don't have to have every age class. Don't worry. Like, you might not have anyone in these first couple age classes. That's probably a good thing, right? So like, for instance, if I didn't have anything from 16 to 20, I could simply go up to 21 to 25. But again, you're bidding these into 5-year age classes. So don't worry about that. And then the next column you're going to make is the age. So what's the maximum age for that class? So 0 for age class 0, 5 years old for age class 1 to 5, and so on and so forth. Then you want to figure out, and if you're handy with Excel, there's a number of ways that you can do this with an Excel, Excel um, uh, equation. There's if if you're Excel handy, or if you're good at Googling, you can figure out how to do this relatively easy with an Excel equation. But you basically want to figure out how many people died in each age class. So for instance, in my age class 0, I had no deaths. In my next age class, I had 5, 10, 15, and then eventually 20. So basically everyone in my data set, this hypothetical data set I have here of 50 people, everyone died by the age of 20, which is obviously kind of a awful thing to think about, but that's what happened. So once we have the number of deaths, we want to figure out how many survivors we have. Now, to figure that out, you simply, for the first age class, you would simply do 50 minus how many people died, right? And that's pretty straightforward. If I had 0 deaths in a total of 50 people, or maybe in your case, you have 400 people, my total survivors would be 50, yeah, or 400, or whatever your maximum is. And then for the next one, you simply say, okay, in the next age class, if I lost 5, I want to know how many people died in the previous age class minus how many people died in this current age class, and kind of essentially use Excel to calculate it for you. That sort of drag down function, which is obviously very helpful in Excel. From there, you want to calculate proportion surviving. Now, this one's pretty straightforward. You take how many people you have surviving divided by your total number of people. So in my case, it's 50. Yours would be 400. And you simply divide it by 50. So my proportion surviving is 1 in my first age class, 90% in my second, and so on and so forth. And then from there, you want to calculate survivorship per 1,000. Now, for those of you that have been paying attention to sort of COVID death numbers or infection rates and stuff like that, we typically, when we're thinking about large populations, we report them in hundreds of thousands or per thousand. It's a pretty common way of statistically reporting things. So we're going to do that here as well. So you're going to calculate survivorship by 1,000, and it's actually very, very straightforward. You simply take 1,000 and multiply it by your proportion surviving. So in this case, it's 1,000 times 1, giving me 1,000. The next one would be 0.9 times 1,000, giving me 900, and so on and so forth. And that's all the sort of Excel math you have to do. Now, this is just one hypothetical group of 50 people I have, but you want to make sure you do this individually for each of the two groups you're comparing. So if I have one for males, I'd want one for females as well, because you want to calculate the survivorship for each group independently. We don't care about what the whole trend looks like. We want one for category A and one for category B. So again, it could be males, females, black, white, north, south, Europe versus Australia. It doesn't really matter. But you need a curve for each group. And then from there, you want to make a simple plot. This is going to be the survivorship curve. It's very, very straightforward in terms of how to make. The plot you're making is the age class. So it would be the second column here on the x-axis, and the number of survivors on the y-axis. In Google Sheets, as well as Excel, it's simply insert, and then it's like chart or figure. In Excel, I forget what it is. And you get a graph that looks a little bit like this. Again, where I have the number of survivors per 1,000 and the age class on the x-axis here, and you get this nice little curve. Now, we'll learn what these curves mean and how to interpret them, but you're going to have two curves, one for, in this case would be males, and then I'd have one for females. Those, you just want to make sure you have two curves overall. And you want to make sure you label the axes. So you want to know that the y-axis is this and the x-axis is this. I don't care if there's a title. I think titles on graphs are stupid. That's just my opinion. It doesn't have any reflection on how important titles are. That's just my personal opinion. But as long as you label your x and y-axis, you'll be all set to go. So that's the sort of the way you go about doing this. Again, you can collect this data online at this website I've provided. And remember, this website is located in the handout for you. You just come here to this highlighted part, click the link, it'll bring you to our cemetery website. And again, simple Excel and simple Excel math, simple Excel plots, and that would bring you eventually to this this handout here. And then it basically tells you how to do it, right? What's your question? What's your hypothesis? Here's, basically walks you through all the things I did. And here's some questions for you to answer. These questions will make a lot more sense, especially this last one. Once, essentially once you hear the lecture on Thursday, this will become a lot more apparent, just as a note. So But again, it's a very simple lab, but I think it's a pretty cool lab. It's relatively easy to do, but it really highlights, how we can ask a question and use publicly available data to answer, I think relatively cool question. My favorite one, just as a note, is always north versus south. It's very, very stark. If you compare Alabama to Massachusetts or even Texas to Massachusetts, it's really, really stark, like the difference in these curves that you generate, which I think is kind of a cool thing, kind of a cool thing to see. Just because how culturally different the North and the South are from one another. So, but again, join a group or don't join a group. It is really up to you. Collect some data points, make some graphs, answer some questions. And again, it doesn't take very long. You're talking about maybe, I don't know, start to finish, maybe an hour. Tuesday at like midnight when it's due. So, the sooner you start it, the faster you can sort of suss out any problems you have. But it is very simple. If you have any problems with Excel or anything like that, please let me know. I don't want that to be a barrier to you to doing this. Um, so if you have Excel problems or you're just not very good at Excel, just let me know. Be more than happy to help you out with it or what have you. So, does anybody have any questions on the lab? Like I said, I think it's pretty straightforward, but I've done this
I
lab
just
a
have a
lot.
quick question. Does it matter whether we use Excel or the Google spreadsheet, or should we
No,
stick to Excel?
you could do whichever you like. They're the exact same thing in my opinion. Um, so whatever you're most comfortable with. Um, so like I'm just on a Chromebook right now, so all I have access to, well, not all I have access to, but the easiest thing I have access to is Google Sheets. So again, if you have any questions along the way, please let me know. And like I said, Thursday will make a lot of this population stuff a lot more clear. So you might read some of these questions in the handout. And you might go, I don't quite get where we're going at. But again, we're going to talk about population stuff, urbanization on Thursday. So again, it'll become a bit more clear in terms of what you'll need to interpret these things.
Professor, does only one group member need to turn it in, or does each person have to?
Yep. So as I mentioned, please please sign up for a group. Even if you're going to work by yourself, please just let me know. I will create groups on Blackboard, and you can carry those groups through to work on the next two labs as well. And you'll just have to turn in one per group. But again, if you're going to work by yourself, please just let me know so I know you're going to be by yourself, and I can create your own little separate group. But again, you only have to turn one in per group, which is why I encourage you guys to work in groups because it means less grading for me, which is obviously a really awesome thing. But it also means less work for you guys. And I'm sure you guys are probably
When will you create the groups, Professor?
I just need to know who's going to be in the groups first. So
Okay, that's
like
perfect.
yeah, once this is my other section of this class, but for you guys, there's about 24 of you here. I noticed, it's pretty full. It's much more full now. So for instance, like I'll start making groups today. I'll put group 4 will be their group, and I'll put group 6 together, and you know, I'll wait a couple days to create all the groups. But yeah, so you don't need to worry about the group part until it's time to submit. So you don't need to worry. Like you don't need to worry about that. Just let you know. Just work together, and when you're ready to submit, it'll be ready for you to turn in one copy per group. You all get the same grade, so you don't need to worry about that. That's on me. Just sign up for your group, work together, ask me questions, enjoy looking at dead records of dead people. Though I will say I like this lab better in person because we get to go to when we usually do this lab, we go to Arlington Cemetery in Cambridge, which I don't know if you guys have ever been to Arlington Cemetery in Cambridge. Really nice cemetery, really, really big. Awesome historical graves of some really famous people like Thoreau and stuff like that. So it's usually a pretty cool day to see some awesome history and stuff like that. So, but obviously we're not in person. So, all right. Does anybody have any more lab questions? Okay, so I apologize if you guys can hear any. I don't know if you guys can hear. It's all I can hear. There's my neighbors getting their driveway done right now, and their driveway is unfortunately right behind it, right behind the window that I'm sitting behind, which is my kitchen, or actually say my dining room. So Sorry if you hear any banging or anything like that. That's unfortunately nothing I could do about that. So, all right, so we're going to talk about, I think, something that will interest you quite a bit, and it's trying to put a monetary price tag on nature. How do we evaluate nature from an economic standpoint, and why does nature have such a astronomically high value? Any questions along the way? If you need something clarified, you want me to expand on something, you think something's cool, obviously feel free to um, let me know in the chat, or if you want to just speak up, that is a-okay with me as well. But let's get started. So we'll start off with this comic. I found this comic a number of years ago, and it's not a funny comic or anything like that. I think the comic I have for climate change is funnier than this one, but this one's not very funny. And this guy with a really big mustache and a really big nose, stereotypical angry dad, I guess, says, as you go through life, take time to monetize the roses, which is in direct contrast to take time to smell the roses. So take time to smell the roses, obviously, take time to enjoy life. Take time to monetize the roses is to take time to monetize. Well, I always interpret it as anything, but you might try to interpret things that are good however you'd like to interpret it. But that's what this guy's getting. And it's a pretty good reflection of what sort of themes we're going to be talking about today, and what sorts of I guess choices we make when we're thinking about nature, and how we really perceive when nature is good and when nature is bad. So let's dive in. But before we do that, we have to define an ecosystem. Now, an ecosystem is something you guys probably all know of, but you probably didn't sort of know the technical definition of it. So for those of you that like nature documentaries, you'll hear things like coral reef, or tundra, or taiga, or temperate forest, or rainforest, or desert. All those terms I've sort of threw out there, that is an ecosystem. Those are just different types of ecosystems. Now, an ecosystem broadly is simply all the living things and how they interact with each other, and how they interact with all the non-living things. Now, we collectively call everything that's living. So from all the tiniest bacteria out there up to the largest things out there like sequoia trees and blue whales, those are our biotic components, i.e. the living things, and the non-living stuff are abiotic. So biotic and abiotic, you'll see these pretty commonly in scientific jargon, living versus non-living. Now, biotic components are broken down into relatively few categories, where we have herbivores, i.e. plant eaters, detritivores, i.e. I eat dead things, lots of those out there, carnivores, meat eaters, primary producers, plants, algae, bacteria, things that do photosynthesis basically, and then omnivores, which kind of straddle the line of herbivores, detritivores, and carnivores. So omnivores are like us, we eat anything, right? Plants and animals, right? And so those are the living things. And then we have the non-living stuff, which is arguably a much longer list. I've made them equal um, sizes, but that's just not really an accurate reflection. There's far more abiotic things in the ecosystem than biotic things. And this include things that you think about every day: sunlight, temperature, wind and water, but also things you might not think about, like geology, right? Rocks. Also, you might think of terrain, right? Things that are not living, those come together to make our abiotic things. And now, interesting thing about an ecosystem is we tend to separate the living from the non-living, right? We think rocks are separate from, say, plants, but that's simply not the case. Ecosystems are dynamic. They change over space. So for instance, if you go to a mountain, the ecosystem of a mountain looks different at the bottom than it does at the top, right? Or the ecosystem of my backyard looks different than the ecosystem in the woods behind my backyard, right? So ecosystems change in space, but ecosystems also change in time. So my backyard looks very different in the winter than it does in the summer, right? My backyard is happy and living in the summer, and pretty sad and dead in the winter, right? So they vary through space and time, and an ecosystem is pretty dynamic, and the abiotic influences the biotic, and the biotic influences the abiotic. It's a really nice system. Ecosystems are very dynamic. They change quite a bit, and they are much more, I was going to say chaotic, but that paints the wrong picture. They're much more interactive with one another than you would really think. Now, we have an important term that's going to pop up quite a bit, which is what we call ecosystem integrity. And ecosystem integrity basically refers to how well an ecosystem is functioning. An ecosystem that has high levels of integrity functions really well. An ecosystem with low levels of integrity functions very poorly. And you can really relate ecosystem integrity to ecosystem health. High integrity equals good health. Low integrity equals bad health, right? So you could think of like nice pristine forest has high integrity, good health. Uh, Ditch on the side of the highway has low integrity, low health. That's sort of an easy way to think about it. Now, there's a really interesting interplay between how ecosystems function and how biodiverse they are. Now, remember, biodiversity simply refers to how much life I have. So, a place that's has a lot of biodiversity simply means there's a lot of species living in that defined area. Now, there's a really interesting link that more diverse ecosystems, i.e., more species, have better functioning ecosystems. Now, it's kind of a weird concept, and it holds true pretty much everywhere on the planet except for a few weird places. But to give you an example of what this looks like, if we take a hypothetical aquatic ecosystem, so like a pond or a river or a stream or something like that, and there's phytoplankton, or what you would call algae, floating in the water, and these algae like to remove nutrients from the water. It's kind of what they do. You can think of nutrients like, like fertilizer, stuff like that. Now, what these algae do is when there's one species present, they have actually very, relatively speaking, low nutrient removal efficiency or potential, whatever you want to call it. But if we increase the diversity of that algal ecosystem or the phytoplankton ecosystem, we increase nutrient removal efficiency. Now, why is that? It's a really complicated answer, but just to know, more diversity equals better functioning ecosystems. If you want to read a little bit more about this, this Coastal Wiki website down here at the bottom is a really interesting read if you've never come across, or maybe this concept interests you. But again, high biodiversity, better ecosystem functioning, and it would really behoove you to remember this idea of why biodiversity is important for ecosystems, because it kind of gets trapped. It kind of gets lost along the way in a lot of sort of thinking about why preserving life is important. So definitely keep this in the back of your mind going through the course. I'm not going to ask you a question on the test or anything like that, but it'll pop up, not directly, but it'll pop up throughout the remainder of the course. So now, this wouldn't be an environmental science and sustainability course if we didn't talk about how humans influence ecosystems and what ecosystems do. And there's a number of ways humans influence ecosystems, and there's really sort of no end to where this occurs on the planet. Doesn't really matter. And this includes things like overfishing or overtaking, polluting the environment with nutrients. So this is like a septic. This is like runoff from like sewage pipes and stuff like that. Introduction of invasive species, deforestation, changing rivers to cause sedimentation, and then things that are maybe longer term, such as climate change. Though as a note, I love this polar bear's face in this picture, because he just kind of looks like he's like saying what's up. I don't know. I use this picture for a lot, and I always thought the polar bear looks funny. It's obviously a sad picture, but he looks funny. He's like, "What's up? I'm just hanging out of my iceberg." So human pressure on ecosystem affects both the biotic and the abiotic components. I hope you can see that here from all these sort of different things. And they could be together or in isolation. So you can overfish and change the climate and pollute and change sedimentation all within a single ecosystem and dramatically change said ecosystem. So just as a note, they're not in isolation. They oftentimes work together. And just to sort of highlight what that looks like, here in Massachusetts, we see pretty heavy amounts of nutrient pollution and species introduction in Boston Harbor. Um, and again, they work together to change the way Boston Harbor functions as an ecosystem. Now, ecosystems, they just kind of doing their thing, right? They don't exist to serve humans, but in humans inherently derive either directly or indirectly some services from ecosystems. And it's just kind of how we are, right? We sort of like to think of ourselves as being separate from nature, right? We live in houses, we live in cities, right? We don't think of ourselves as like mountain men, right? Like I go harvest wood to build the things that benefit humans, again, either directly or indirectly, and we'll get what that means in a moment, are called collectively ecosystem services. Now, ecosystem services is not really a scientific term; it's more so of a sociology term and a science term, sort of all rolled in together, as well as sort of an economics term. Um, So just as a note. Now, to define an ecosystem services, it's just something that benefits humans. And as you'll see, this is a pretty broad category of things. We take a lot from nature, and you'll see that in just a moment. Now, these ecosystem services have long been recognized, especially by scientists, as being vitally important to the functioning of society. But in 2005, we actually, at a governmental level, started recognizing how important these are to humans. So, for instance, in 2005, the UN had the Millennial Ecosystem Assessment, and they defined 4 distinct categories of ecosystem services that we're going to dive into. And if you want to read a little bit about this, you can read the FAO's report down here. I didn't check this link. I always have to check this. They update it all the time. This should work. If it doesn't work, let me know, and I'll give you the actual link. They changed. I don't know, for whatever reason, like from semester to semester, like I try to use this link and it changes on me all the time. I don't know why. So if it doesn't work, let me know. I'll post the actual link. I forgot to check it this time. But the 4 services here are provisioning, regulating, cultural, and supporting services. So let's dive into those. And we'll start off with the most obvious one. And I think this is the one you guys kind of probably already have the best grasp on, is direct and marketable benefits to humans, commodities I can go to nature and take and sell. Right? It's pretty straightforward. I could be like Nestle or any other water company, take water. I could be like numerous groups, take food from nature and sell it. I could harvest timbers or plant fires and sell those fibers, not fires. Um, I can harvest oil or natural gas and sell that. Or I could do something sort of kind of a funky way, is maybe I can use nature to derive medicine. I'm not sure how much you guys know about drug development, but a lot of our really clinically important medications out there have a level of um, derivative from nature. For instance, acetaminophen, like Tylenol, or aspirin, um, derived from plants, right? So things we take from nature and then sell. And there's no shortage of medicines that are come directly from nature. It's kind of a cool thing. Now, like I said, this one's probably the easiest to understand. I grab something from nature and I sell it. It's pretty straightforward. Now, the next one, we're starting to get a little bit more abstract, but I think sort of still within your realm of easily comprehending. Not that the rest of them you couldn't easily comprehend, but I think these ones are a little bit more tangible relative to the next 2 that we're going to talk about. But these are regulating services that these are the ones that help sustain ecosystem health and ecosystem integrity. Now, these include pollination. Now, pollination, we think of like pollination as not being a super duper important thing, but if you ask anyone in the agricultural sector, for instance, people that grow and remarkably, actually, pollination just naturally provided by nature in the United States alone ranges from about 225 billion to about $500 billion every year, provided free of charge by Mother Nature. It's kind of a cool thing. So pollination is a really big thing for our food. We obviously need food because food's important. Then we also have decomposition, i.e. the breaking down of dead things. So when you throw a sandwich out, that sandwich just doesn't hang around for a long time. Organisms eat it, break it down, recycle the nutrients back into the biosphere. Really important function. Uh, Water and air purification, also very important. Air pollution is a really big health concern. It's also a very big economic concern. And nature does that air pollution, air purification, and water purification for us perfectly fine for free, which is a pretty cool thing. Flood control and erosion control are also really important things. For those of you that have ever been to has anybody ever here been to Nantucket? The island off Massachusetts, one of the the one that's next to Martha's Vineyard. Um, Nantucket's a cool little ecosystem on its own. It's expensive to go there, but if you ever have a chance to go there, it's a really cool place. But there's one side of the island in Nantucket where people have been moving their houses every couple of years because there's so much coastal erosion on Nantucket. They lose about like 10 feet of cliff and beach every year. It's kind of a wild thing, but nature does help protect against erosion control. That was the point of the story. That nature does help protect with erosion as well as controlling our floods. Nature also helps us regulate our carbon budgets as well as our climate as well. And so ecosystem services that help regulate and maintain ecosystems health, again, all vital to the functioning of an ecosystem. Then we step up again into something that I think you guys probably experience without even realizing that it is an ecosystem service. And this is actually, again, something I think pretty cool, which is our cultural services, i.e. our intrinsic connection to nature. I'm sure everyone here has probably gone on a hike. I'm sure people here have probably seen architecture or music, or potentially art that is inspired by nature in some shape or form. There's many religions that take spiritual sustenance from nature, like they have a direct connection to nature. And then you have people like me who make an entire career out about teaching people how awesome nature is. So cultural services, i.e. our intrinsic connection with nature, is an important thing that nature provides for us. And I'll show you sort of the dollar values of how these break down in just a moment. And actually, this was first coined by this gentleman here. If you guys might remember him from our first class together, this is E.O. Wilson. He coined this idea of cultural service as biophilia, which is i.e. our human intrinsic connection with nature. So kind of a cool thing. Nature is important. There's all sorts of correlations between people spending more time in nature and having, lesser heart attacks and like less diabetes and all sorts of crazy things. So cultural services and being connected to nature is a sort of pretty wide swath of things it provides for us. So I think the moral of the story for this service is go be in nature. It'll make you healthier in some way, shape, or form. So. And then we have the final one, which is supporting services. And again, these are the most probably the most abstract of them. And these are basically the essentially the underpinnings of nature. This is like the bedrock. If you were to put like a pyramid of things, this is at the bottom of the things, then followed by our other services, because these are the things that keep nature functioning: photosynthesis, cycling of nutrients, making soil, cycling water, and making brand new habitats. That is the bedrock of just making an ecosystem be an ecosystem. So again, a little bit abstract, because we know plants are photosynthesizing outside, but we don't really see it happening, right? I mean, we breathe the oxygen of the plants, but we don't really see it happening, right? So again, a little bit abstract, but again, critically important for the functioning of an ecosystem. So we have our 4 categories: the background ones, our cultural part, the regulation, and the direct marketable goods. The question we can ask is, can on nature? So let's dive into that question. And it started back in 1997. If you want to read a little bit about this, check out this reform.org link down at the bottom. But it did start in 1997 by Costanza et al. I see Costanza et al. And I think George Costanza from Seinfeld, but it is obviously not George Costanza from Seinfeld. It's a scientist named Costanza. And so in 97, Costanza and about 25 other people worked together to try to assign a dollar value to all those 4 ecosystem services across the planet. And when they did that in 1997, with all the math they had, with all the knowledge they had, they came to a value of about $33 trillion. Now, in 2011, and I know that seems like a long time ago, but the numbers actually still add up. Even 10 years later, in 2011, they revised that number to be about $125 trillion. So that is the direct value of nature. Now, does anybody know, and I think this is kind of an interesting thing, does anybody know what the GDP, the global GDP is every year? It's like a ballpark number. You guys should, I feel like you guys, of all people, should know this.
Isn't it something like 80 or 90 trillion or something?
Yeah, it's about like 83 trillion last year. And I'm sorry, in 2019, so non-pandemic time. Yeah, it's about like 80 to 90 trillion in that ballpark. That's good. Which is obviously a lot of money. But putting that in perspective to how valuable just ecosystem services are, and you'll notice in these ecosystem services, there's no like meaningful like property, right? It's just like things that have value. It's a lot of money, right? 120 trillion $125 trillion. It's a lot of zeros for those of you keeping those of you keeping track, right? I mean, that's no small amount, right? That's 5 times the yearly US GDP, right? So it's kind of I don't know, maybe I don't know, maybe you guys think more about money than I do, but it just like every time I see it, it's always like, wow, that's kind of amazing, right? That's a super valuable planet. I see some people are chilling on their couches and they're like, yeah, that's pretty impressive. You know who you are. Which is kind of cool, right? Now, when you start to break down this paper, and if anyone wants to read the papers, I'd be more than happy to post them. I usually don't because they're pretty boring, but the conclusions are obviously pretty spectacular. But each physical ecosystem is worth slightly differently. Now, the most valuable ecosystems include seagrass beds and wetlands at $14,000 plus per hectare per year. Now, a hectare, for those of you that have never heard of a hectare before, is about 2.5 acres. So it's a decent sized parcel of land, but not huge. The most valuable ecosystems are actually floodplains. So parcels of land that help control floodwaters. Because as you guys probably know, floodwaters cost billions of dollars of damage every year. They're super duper destructive. And now to put these numbers in perspective, does anybody know how valuable a hectare of cropland is worth? Anybody want to take a guess? If I was to grow 2.5 acres of soybeans, how valuable is that cropland?
Depends on the crop and the location of the hectare.
True, but like just the direct service, just give me a guess. Just say average. What would you guys guess? Throw out a number or numbers. What do you guys think?
Let's say 5,000.
Okay, 5,000. That's high, but good guess. I was expecting, usually the first guess is always like 15,000, but that's a good first guess. You're close, but a little bit high. Anybody else have anyone else want to throw out a guess for funsies?
4,000.
Getting closer.
2,500.
Right on the money. Yep, they're about 2,500 and change per year. So a single piece of cropland, which obviously is really important, right? We need to grow food, but again, it's only valued at about 2,500 bucks per hectare. So not a lot of money, especially relative to something inconspicuous as say a wetland, right? So again, ecosystems have variable amounts of value, and they all again tie back to those 4 ecosystem services, which I think is a pretty cool sort of way to think about ecosystems. Now, why do we care about how valuable these ecosystems are? Well, when something has value, it leads to commodification, and we'll talk about that in a second. But one way that we could argue about why, yep, go ahead.
I'm sorry, I was just looking it up. A hectare in Colombia is worth $6,000, upwards of $6,000.
Just a piece of land, or
Yes, in Colombia because of the climate and ecosystem, like property, like it's better and it's easier to grow things here. But like if you go to Asia, it's gonna be like 2K, like 1K, like it depends.
yeah, it's a good point. Yeah, it does vary pretty heavily. A hectare of land around here in Massachusetts is not worth very much because our soils suck. And all those
Yeah, it's soil quality.
Yep, all that acidic and rocky soils here in Massachusetts, not worth too much. But someplace in like the Midwest where they have 10, or at least they used to have 10 feet of topsoil, much more valuable. But as we'll, we're not really going to talk about this too much, but ecosystem services change in value over time. So this number of of a wetland now at 15,000, as the wetland becomes degraded over time, it's going to lose its value. The same thing for cropland. So that parcel of land in maybe Colombia or in the Midwest that's very valuable, as we overuse it, right? We tragedy commons it. It's going to become less and less valuable over time. So that's a really good point. Now, valuing ecosystem, it's interesting, but when we try to put a value on an ecosystem, it might be a handy dandy way to think about how we develop land, right? Clearly, the human population is expanding, and we'll talk about how it's growing next class. But if we're thinking about how to develop land, saying land that otherwise just looks like a forest has X dollar value per year might be a good way to think about how to sustainably develop said land, or potentially how to restore a damaged ecosystem to regain that loss capital. Now, one of the things people are worried about, and so in this article here in 2006 by Macaulay, he argued that the monetization of any ecosystem or any piece of biology does lead to commodification. And I think that's not a bad way to think about it. I think anything that has the potential to make money, there's probably someone trying to make money off of it, right? And that doesn't really, I don't really think it matters what it is. If you find like an old gross mattress on the side of the road, there's probably someone who thinks I can make money off that by fixing the mattress up and selling it, right? So if there's an opportunity, monetization probably will follow shortly thereafter. However, our friends Costanza et al. Did argue that when you value something, it's not the same as privatization. So if by keeping things a public commodity, i.e. keeping it as a public good or service, does not necessarily mean it's going to be commodified and sold. So clearly there's two opposite ends of the spectrum here. Commodification is bad. Commodification puts a good value on nature, thus convincing people to save it. So let's talk about how we can do this. Now, I'll just leave you with this little chart here. You can take a peek at it at your leisure. I think it's kind of a handy dandy chart to think about some of the things we talked about. But let's dive into a case of how commodification actually made the case for fixing a damaged ecosystem. Now, the ecosystem we're going to talk about is the Florida Everglades. For those of you that have never been to the Everglades or have never heard of the Everglades, this is the Florida Everglades. It's the river of grass down here at the bottom. And arguably, it's one of the most beautiful ecosystems that has that I've ever been to, at least, but arguably one of the most beautiful ecosystems on the planet. And again, it is a river of grass. It is a wetland. It's covered in what's called sawgrass. That's what you're seeing here, just lots and lots of grass. But it also has mangroves, which are a really fun ecosystem, swamps, as well as prairies. So it's a really, really diverse set of ecosystems coming together in central to southeastern Florida. Really, again, really, really beautiful place. So if you've never seen like a National Geographic documentary about the Florida Everglades, I recommend you find one because again, really spectacular place. Now, this wetland does a lot of fantastic things. It's home to some really unique creatures, including alligators. There's lots of invasive species there, like pythons, but including to some what we call endemic species, including the Florida manatee. Manatees are a fun group of organisms. I recommend if you have a few moments that you Google manatee flippers because you'll notice because manatees are mammals, so they share an ancestor with us. Manatees actually have fingernails on their flippers. It's kind of a fun thing, but they're also just some of the, at least in my opinion, they're some of the cutest, like dopiest looking creatures out there. So Florida manatees, again, endemic, i.e. found nowhere else but the Florida Everglades. So really impressive biodiverse area. In addition to all the cool biodiversity, people use it for recreation, for culture. There's lots of science that goes on there. Or of engineers. And as much destruction as the Army Corps of Engineers has done, you have to truly marvel at how impressive the Corps of Engineers actually is when they set their mind to something. Because when the Army Corps of Engineers decides to do something to nature, they do it and they do it real fast. My guess is it's probably all that sweet military funding that they get on a yearly basis. But they're no joke in terms of a group that does construction. Now, the Army Corps of Engineers essentially drained most of the Florida Everglades. So we can look at the historical flow of the Florida Everglades, again, flowing down from the Tampa Bay area, Tampa Bay is in this area, down through Orlando and all that fun stuff, and draining out into the Gulf of Mexico and the Caribbean, Atlantic Ocean, whatever you want to call it, and down into Miami. So it's a pretty long river. It's a pretty large ecosystem. And again, pretty important ecosystem. Now, the Army Corps of Engineers, as well as with Florida people, but I think the engineers from the U.S. military get their due here, is they dramatically diverted the flow, and they diverted the flow away from southern Florida out into So you can imagine changing the river part is kind of a big deal. And you would be absolutely right to say that it was a big deal. So this is where we are, dramatically changing the Florida Everglades. So what are some of the consequences of changing this? Well, pretty much when they started diverting the water, they noticed the effects almost immediately. And I wouldn't say that the effects were overly surprising, right? I think diverting that much water is has pretty upfront consequences, for to say the least. So, what happened to it? Well, one of the things that we saw in Florida was actually the disappearance of this ecosystem here. It's called the pine rockland ecosystem. Really cool ecosystem. It's only found in the Florida Everglades. Now, because of the diverting of water, this is actually one of the most endangered ecosystems in the world, and certainly the most endangered ecosystem in the United States. So we're basically losing an entire ecosystem. We're also losing surrounding habitats. So, for instance, the India River Lagoon is basically a shell of its former self. It used to be a really vibrant area. Now, because they diverted so much water away from it, it's basically almost a non-existent sort of thing. It's kind of a sad thing. In addition, we saw the massive loss of seagrass beds and the Florida manatees that depended on them. And we also saw a loss of actually two really important fisheries to the state of Florida, the bonefish and the tarpon fish. So not exactly the best thing. Now we could think about why this might be the case before we sort of go on. And I think it's pretty straightforward to know that Florida is a pretty heavily developed state. It's the third largest state in the country. It's the third or the fourth most populous state in the country. I never remember. Can't remember if it has more people than New York or not. So it's the third or fourth most populous state, and the for this ecosystem. Certainly not for the Florida manatees. And look how cute that guy is. He's so cute. So why are we talking about the Florida Everglades? Well, we're changing the ecosystem. Thus, we're changing the ecosystem's integrity, its health. Thus, we're losing ecosystem services. And we can see the loss of a single ecosystem service right here. We know provisioning services, i.e. fisheries, were lost. So what other ecosystem services were lost from the Florida Everglades? And we'll talk about that in just a moment. But we're talking about the Florida Everglades because the Florida Everglades is actually a great place to think about how putting a dollar value on the ecosystem convince people to restore said ecosystem. Now, ecosystem restoration is reactionary. It's in contrast to ecosystem preservation, which just keeps ecosystems intact. Ecosystem restoration is fixing problems of the past, right? That's sort of what it is. Now, this was done by Congress in 2000. So the Comprehensive Everglades Restoration Plan, or SERP, arguably one of Congress's last great environmental things. You guys probably recognize 2000 as sort of, or maybe you guys are young. You guys were like 10 when this came, when SERP happened. But 2000 was, I'm sure many of you probably know, is when really partisan politics really kicked in, and so not a lot of good things happened in Congress after 2000, unfortunately. But one of the last great hoorahs of Congress before it got super partisan was SERP. Now, SERP was about 50-year project, and it was estimated to cost about $11 billion, and that's what Congress allocated funds for. And at the time, and as the time we're currently living in, there's still people who say fixing environmental problems is too costly and we should just ignore them. So some people said they were just too expensive and that the benefits would outweigh the costs. So we'd invest $11 billion, but it would essentially, we would not get back even close to $11 billion from this thing. So that's the reality of it. Now, there was also some environmentalists that were saying it's a waste of time because we couldn't fully restore the ecosystem. Right? That's kind of a nihilistic approach to it, but it is true, right? Once you change an ecosystem, you can't bring it back to the way it was, but you could try to find a balance here. So let's talk about the dollar values of SERP, because again, putting a dollar value on ecosystems shows they're valuable, but it also might convince people to preserve and protect our ecosystems. So let's look at SERP by the numbers from this sweet lime green table. Now, the ecosystem services that SERP put forth as restoring over this 50-year period, including about $13 billion for groundwater purification, $16 billion for real estate, i.e. people like to live near nice ecosystems. You know, you think about all the people that here in Massachusetts that were up in arms that we were going to build wind turbines off and destroyed their views. People like to live near nice ecosystems. Park visitation at about $1 billion. Open space just for people and events and stuff like that at about $830 million. Fishing, both commercial and recreation, at about $2.5 billion. And hunting and fishing licenses at about $12.5 billion. Again, over about that 50-year period. So, grand total, we invested about $11.5 billion. And over that 50-year period, we're getting back about $46.5 billion. And if you do an ROI calculation, so this divided by this, you get an ROI of about 4.04. So I'm sure you guys probably know what ROI means, but just in case you forget or you don't know, an ROI just means if I invest, an ROI of 4.04 means for every dollar I invest, I get $4.04 back. So pretty good investment, like really good investment, especially when it's just passive, right? You don't have to like harvest stuff, right? It's just like doing things nature does, purifying your water, letting people build near it, right? Things that are just going to happen normally, right? Things that come at really no cost to the state or the federal government. So you could also imagine these are just like things that like come out of it, but you can imagine like there's also other things that come out of this, right? If I sell $2 billion worth of fish, there's crap tons of taxes that come back to the state and state, local, and federal governments as well. So it doesn't just help like local economies; it helps the national economy as well. So just as a note, there are some other financial things that go into this as well that make this a really, really valuable investment. And I sort of look at these and I kind of go, yeah, well, that makes sense. But a lot of people will argue that even though this ROI was great, the investment was still too high. And we hear this argument quite a bit spread throughout environmental science. The cost of doing these things or fixing these things or trying to avoid damaging ecosystems is just too high. But the reality is that's just utter nonsense. No matter what environmental issue is out there, the ROI for almost all environmental investments looks like this. For the investment you get way more out of it, and it's not, and it might not be like, oh, the oil company doesn't get benefits from it, but everyone else gets benefits for it, right? Everyone's entitled to nature, everyone's entitled to the fruits of nature, not just a select group of people. So that is ecosystem valuation. I hope I've sort of illustrated the point of what ecosystems provide for us. Also, the fact that we are not distinct from our ecosystems, even though we like to think we are, and that ecosystems are worth protecting, they're worth preserving, and um, um, they're worth keeping around and trying to figure out ways to develop sustainably. I hope I've convinced you for that. Maybe I didn't have to convince you at all. Maybe you already knew. But I hope if you were on the fence or you didn't know or whatever, I hope I've convinced you at the value of ecosystems, both directly or indirectly for you. And again, as we'll learn sort of later, once ecosystems are gone, it's really hard to get them back. Once species are gone, once biodiversity is gone, it's really hard to get it back. So sort of the best way to think about this is not so much in the case of the Florida Everglades, but like in terms of like not letting what happened to the Everglades happen to future ecosystems. That's really sort of the way to think about it. Keeping terrible action to this. I've sort of touched on this a little bit. Sustainability, sustainable development, really what So does anybody have any questions about ecosystem evaluation, ecosystem services, dollar bills? I saw at least 2 people smile from that dollar bills joke. Okay, so we have a second little aspect to go. So we've been in class for about an hour. Do you guys want to break?
Whatever you want to, Professor.
All right, I'm gonna take the silence to mean that you guys don't care. So I'm gonna go on. I say you don't care as in not like a bad thing or anything like that. Just like no one has an opinion. That's fine with me. I don't have.
Professor?
Yeah.
I think you keep like cutting in and out your audio. I think when you asked if we wanted to break, we said some things and I don't think you heard us. I don't know if it's like your internet or what it is, but
I don't know what it is.
I don't know
Yeah,
if it's there
your
now.
audio cuts in and out sometimes, and like I feel like when we speak to you, it also like cuts out sometimes.
Huh. I don't know what it is with this account. All right. Yeah, I don't really know what to do at this point. All right. Does anybody have any opinions on keep it on, or moving
I
on?
feel like when you have your camera off, it's better.
Yeah, I'll keep my camera off from now on. I don't understand why it does what it does. It shouldn't. It's the internet here is great. I don't know why it's I don't know. The weird part is though is I teach with Blackboard too, and Blackboard never has this problem. It's just Zoom. It's just this Zoom account for whatever reason. So, but did anybody have any objections to us continuing to the next part of our adventure? I'm not hearing anything, so I'm assuming that's a no. All right. So part 2 is ethics, economics, and policy. It's good. It's interesting stuff. Sort of the thinkings that historically have gone into environmental policy, but the reality of it is a lot of the stuff we're going to talk about today essentially just doesn't exist in a lot of modern economics, policy, and ethics surrounding sort of environmental policies, unfortunately. And that'll become apparent as we sort of talk about these things. Just simply because the discourse around environmental policy has become so polarizing and so partisan that even scientifically accepted things are becoming lightning rods for people to disagree on, even though when there's no room to disagree on. So let's talk about these things. So the question we'll sort of dance around is, how do we make decisions that protect our environment? And so how do we address how complex the environment is, right? We talked about how valuable ecosystems are, and that's, even though ecosystems are super valuable and they've been shown to be super valuable for decades now, people still ignore the value of ecosystems in favor of their own personal view of the environment. So how do we make decisions? How should we make decisions regarding the environment? And essentially, how does that translate to global, local policy levels and things like that? So let's dive in. So I'll give you an example of environmental issue. And so this is when you guys were, again, little kids. uh, so this is going to be in 2010. For those of you that have never heard of the Deepwater Horizon oil spill, this is from British Petroleum, or BP. They spilled about 5 million gallons or barrels of oil into the Gulf of Mexico, and you can sort of see this awful sort of scenario, right? This tanker on fire, firefighting boats trying to put it out, just massive environmental disaster, and that looks bad. But I hope you guys can see the water here. It's just black, and the water's black because of oil, right? and and this looks awful. The fire looks awful. The oil looks awful. But the extent of the disaster is what is truly awful about this scenario, where we have all this orange here in the Gulf of Mexico, so Louisiana, Alabama, and Mississippi, all negatively affected by this massive, massive oil spill from British Petroleum. And again, I can't highlight how disastrous this is. This is one of the worst environmental disasters that has ever happened, not just here in the United States, but also just sort of at a global level. And again, it's truly a huge scope here. It really, really is. I can't sort of highlight how serious of a disaster this was. And you can see where the disaster occurred and how far it spread, right? All the way up into Florida, right? I mean, it's a pretty big thing. Now, this oil spill clearly is bad for the ocean, but and all the things that live in the ocean and all the plants that are on the coast of the ocean, but it's also bad for humans. People lost the way I've been describing it as this horrible, terrible thing to really this kind of the price of doing business sort of thing. Um, and so the ethics around these sorts of environmental disasters start at really a personal level of what you sort of believe nature is valued to be. Like BPA free water bottles. Now, what is BPA? Well, we'll talk quite a bit about BPA later in the semester, but BPA stands for bisphenol A. So BPA, bisphenol A. Now, in 2010, the FDA reported that bisphenol A, that's found in numerous types of plastics. It's called a phthalate. It's this PTH thing. It's a plasticizer, makes plastics more durable, harder, more resilient, things like that. BPA was found to actually be hazardous not only to adults, but also to developing infants. So BPA is a wild chemical. It has a pretty cool history, but it does mimic hormones, which is what makes it so damaging to developing individuals. Now, the FDA issued a warning about it, and people could either choose to both individuals, i.e., I'm going to boycott products that have BPA in them, or companies also showing some, I guess, financial incentives to promote and market products that are BPA free. So you guys have probably seen these quite a bit. Lots and lots of companies will advertise, like for instance, like Nalgene or Camelback. Those companies will advertise BPA-free water bottles, and so we see sort of this personal ethics come into play, where the federal government says this is bad, and people are deciding based upon their own personal ethics whether or not they should consume products with BPA in it. Now, as I mentioned, we'll talk about plastics later in the semester. We'll talk about bisphenol A later in the semester. So don't worry, we'll come back to BPA if you have any questions about it. So but sort of using it as a good example as how people chose use their own sort of personal guidance to choose or not choose to essentially ignore scientific advice or accept scientific advice on something. Now, this leads us to sort of a really bedrock foundational ethics idea, which we call rights and duties. Now, you sort of see this play out in the public sphere quite a bit. And people won't necessarily call it rights and duties, but it's really that's sort of how it's ontologically defined. But generally, people believe that that parents have a duty to care for their children, and that children have a right to an adequate standard of care. That's pretty commonly found across most of Europe, most of the United States. It's a pretty well accepted idea of duties and rights. Now, this is what we call deontological ethics. essentially a system that's based upon these duties and rights. Now, interestingly, for those of you that know anything about the establishment of the EPA, it was put forth by the Nixon administration as probably one of the only one of the only good things Richard Nixon did. Uh, Nixon was a really interesting president. If you don't know a lot about Richard Nixon, he was, I mean, obviously the Watergate thing was bad, but he was a really sort of, I'm not gonna say awful dude, but he was a really interesting guy in terms of the way he approached things. But one of the good things Nixon did was actually establish the Environmental Protection Agency, or the EPA, in 1970. One of the most maligned groups in the federal government, in particular by the oil and gas industry, as well as chemical industries. People like to hate on the EPA, but it is a system founded upon this duties and rights, i.e., protect adults protect their children. Children deserve to grow up in a safe and healthy environment. Now, that's the EPA, founded on a personal ethics, but applied to a governmental standard. Now, the United Nations has their own set of essentially duties and rights, which they call the Earth Charter. Now, they established this in 2000, and this is basically outlines 4 pillars of environmental and ethical protections. So you can dive into these if you're interested. But the one we're really thinking about here is actually pillar number 2, which is actually ecological integrity, because this is obviously an environmental science course. But this ecological integrity sort of touches upon 4 key things, i.e., protecting and restoring Earth in the environmental integrity, preventing harm to protect the environment, adopting patterns of reduced consumption, i.e., sustainable, and advancing the study of the environment as well. And the EPA has similar guidelines to them as well, but again, all based upon individual ethics, ethics that are both intrinsically held by people, but also essentially extrapolated to a governmental level. So ethics clearly is important. Ethics vary pretty widely among people. If you ever want to sort of get an idea of that, you can just sort of watch how people, when they're out and about, what they do with their litter, right? Some people have a pretty stringent form of ethics where they will always carry their trash with them. That's like me. I always have pockets full of trash because I refuse to throw my trash on the ground. Then you have people such as my mom who have no problem throwing trash right out the window because, well, I think it's just because she's lazy. But clearly a different ethics system surrounding the environment between my mom and myself. So we can ask the question, how do governments make large impactful decisions, such as building hydroelectric dams that might improve the lives of thousands, but also require potentially destroying the lives of many or few or large numbers of people? So how do you sort of balance those sorts of big idea situations? And it's hard, right? I mean, it's clearly a difficult decision of when to do something, as it should be, right? I mean, it should be difficult to destroy the livelihoods of people, right? That's if we've learned anything from philosophy, is thinking it's tough, but it's certainly an important aspect of being a human. Now, we can approach things through what we call a utilitarian. I'm like, I don't know what it is this word this week. I can't say it. This word, sorry. We'll call it you for now because I apparently can't say it. But we can use this you essentially to define what is right, and we can determine it based upon both ethics, but also sort of governmental standards of how can we do the most good with bringing as little harm as possible. And how do we define whether something is right or wrong is, again, a balance between the good and the bad consequences and what is overall better for the greater good of society, and i.e. utilitarianism. There we go, utilitarianism. That's what it is. Sorry, my pronunciation of words sometimes is just really bad. So, and this idea allows us to essentially calculate total benefits and harms, again, from both not just an ethical approach, but also from an economics approach, right? I mean, you have to sort of think about the economics that go into it. So this leads us to our 3 sort of views of the world. And, we sort of talked about these last class, the ecocentric, biocentric, and anthropocentric worldview, and how we view whether or not to do something related to environmental policy really comes through one of these 3 lenses. So when we think about a big scale problem, like say the construction of a large pipeline, such as say the Dakota Access Pipeline, when we're thinking about something that's like an anthropocentric view, well, building the Dakota Access Pipeline is great for humans because it allows us to transport oil and gas over long distances for cheap, thus providing energy to people, thus lowering the cost of life for average everyday people. So that's our anthropocentric worldview. Now, anthropocentric worldviews, I think it's pretty clear, but I'll just make mention of it, that they have a kind of a range. So when we say anthropocentric worldview, it means humans, but sometimes people's definition of which humans matter varies. Now, the Dakota Access Pipeline is a great example of this. The Dakota Access Pipeline helps some people while destroying the lives of other. So we think about, again, the Dakota Access Pipeline was projected to massively harm people living in the pathway of the pipeline, but it was projected to greatly enhance the lives of people who sought to benefit from the pipeline. In particular, it helped to benefit the people that own the pipeline. So the oil and gas companies, so large corporations. So anthropocentrism as a topic can be, again, pretty wide or pretty narrow, and that does tie back to an ethical view, right? Because if you're going to do something because it benefits your shareholders but it harms the citizens of a town, that's a pretty narrow anthropocentric worldview, right? Versus I'm going to do this because it helps the town. That's sort of a better way to sort of more ethical way to approach a sort of a scenario. So just wanted to make note of that. And then we have our friend, the biocentric worldview, where we think about the animals involved. Now, if we think about something like the Keystone, I'm not sorry, the Dakota Access Pipeline, again, projected to help economics and things like that, but projected to hurt animals in the area, in particular, projected to pretty dramatically hurt ecosystems, right? So when we're thinking about these sorts of problems, it really has a lot of avenues by which to influence sort of the way people think about whether something is good or bad or not. And again, it could be difficult to parse out. And again, people's personal ethics and the ethics of an individual nation also vary pretty heavily as well. Maybe maybe a country like say France has a much higher ethical standard than say Germany when trying to decide whether or not to build a pipeline or something like that. So again, there's kind of a gradient of in anthropocentrism about, especially in terms of an ethical consideration of how best to approach environmental conditions, and it really comes, it's a really difficult thing. It really is, and certainly is a very difficult thing in our current modern political discourse. Now, we care about the environment, as we talked about, because it has a huge economic value, both on a yearly and a long time frame to our planet, right? Trillions of dollars annually, right? Hundreds of trillions of dollars in overall value. So when we think about how we're going to change nature, we have to think about overall how economics factor in the environment as well, because nature has its own value. But remember, we do take economic value directly from nature. And when we think about sort of your average everyday hamburger, if we're going to, if we're for say Wendy's, we're going to sell this hamburger to say me because I wanted a hamburger or something. Single hamburger, about 52 gallons of water to feed the cow to, again, to produce the single hamburger, about 74.5 square feet of grazing for growing crops to feed the cow, and then about 1,000 BTUs, so energy from fossil fuels to create the cow. So ultimately, it requires resources, right? Energy that we take from the land, physical space of land, water, and food we take from the land. So ultimately, the value of something has a direct economic effect on nature, and how valuable said commodity is, i.e., this hamburger, is based not only on how expensive these things are, but also, as you guys probably know, based upon supply and demand. And you guys know what supply and demand is, right? When there is high demand for something, the supply typically goes up. So we can see that with barrels of oil. So dollars per barrel of oil here going up and up and up and up until we hit the financial collapse in 2008, where the demand was really high and the price of oil was really high, and then demand tanked because of the financial recession in 2008, leading to a tanking in the pricing of oil, right? So this little sort of chain here and the impacts of on the environment also scale, right? So the cost of this goes up as demand increases and decreases as supply decreases, right? That's just sort of supply and demand. Now, I'm actually gonna skip this slide, but we can also think about how if there's high demand, we can lower the cost by simply increasing efficiency. We can see that here with coal. We have total cost of coal. I'm sorry, total tons of coal, and then through time, and we can see the amount consumption of coal is really high, drops down, drops down, drops down, drops down, and the power became. Why is it dropping down? Well, it's dropping down simply because efficiency is growing. Thus, the demand is down, which in theory the price should go down, but clearly the price of coal, as you can see here, is going up and up and up as well. I'm sorry, that's the consumption per person. Sorry, but that's the idea. You can decrease costs overall by increasing efficiency of use. Kind of an interesting thing. Now, this leads us to sort of tying all these things together. At least I hope they're tying things together in your brain, which is how economics factor into the environment. Now, clearly, the environment has some overall value, but one of the things that when people start to do the math about developing or harvesting or using a resource is what we call externalities, and things they like to forget. So when we think about again something like the Dakota Access Pipeline, people that are for those sorts of pipelines say, okay, here's all these great benefits, but they ignore these externalities, such as what are the environmental costs? What are the health costs, right? If I'm building a coal-fired power plant, what this might help the economy a little bit, but how much does it cost health-wise to the surrounding communities to build a coal-fired plant? So let's talk about an example of this. And I think a great example of this is actually coal. And I actually really like this. I really like this sort of example because it really has some great modern analogies with it. Now, you guys probably know coal is heading by the wayside. It's a pretty expensive fuel for how much energy you get out of it, and it has all sorts of negative manufacturing connotations. And fully encompassing the entire state of West Virginia, is a really awesome region. If you've never been to the Appalachian region, I recommend it. Really cool area. But the Appalachian region, as many of you probably know, is pretty rich in coal. Now, because it's rich in coal because our country used to be powered in coal, the local economies are pretty heavily structured around coal. Now, if you look at a state like West Virginia, their current governor is a coal man. Like he was the CEO of one of the largest coal companies in the United States. West Virginia is pretty heavily invested in coal. Now, while coal is great as an energy source, it produces energy. I mean, it's obviously not great as an energy source, but it produces energy. And mining of coal has occurred for well over 200 years, and it's been a pretty big staple of this area of the world. It's pretty ingrained in the culture as well. Now, coal might provide some direct economic public due to coal transport, the public health burdens of the communities in the Appalachian area, air pollution, cardiovascular disease, or climate change, the cost of coal is astronomical. And we're not talking about millions, right? We're talking about hundreds of billions of dollars annually. And when you sort of think about that in relative to what coal produces in terms of economic benefits, the costs of coal actually outweigh the economic benefits of coal, which is kind of a startling thing when you start to to the numbers, right? We have all these costs to this area of the world, and not just this area of the world, but the surrounding areas of the world. Coal is nasty. You think about, is there an actual economic or an ethical reason to actually continue to mine coal? And when you start to think about the greater good relative to the economic benefits of this small area of the country, well, I mean, I guess it's not small, but this area of the country, you start to think, well, maybe the costs don't outweigh the benefits here, right? And I would argue, and many scientists argue, that the costs of coal simply outweigh the benefits. There really is no benefit to using coal as a energy source anymore, as much as people in West Virginia would like to think it's a great energy source. It's a really bad, really, really bad energy source. So again, when we think of sort of an ethical approach here, coal is really bad. But from an economic standpoint, the state of West Virginia is still all gun ho about coal. Um, but again, from an economic standpoint, even in an ethical standpoint, really, really bad energy source. So now, when we start to think about how we use the environment, it brings us back to tragedy of the commons. Now, as we discussed, the tragedy of the commons is essentially a vicious spiral, right? As we start to use a resource and we start to overexploit a resource, we start to degrade the resource, which leads to our tragedy of the commons, where we start to diminish the long-term effects or the long-term sustainability of a given resource. Now, we can see this hypothetical example with cows. I like this example because one of my dogs looks like a cow. So I'm always a big fan of cow things. Now, we have 3 cows grazing on this small part of land, and they're doing great. They're getting their food. Then we start to increase the amount of cows, and we start to increase the amount of cows. And eventually you see the grass goes from nice and green all the way to brown. And that's really what tragedy of the commons tells us. We're overexploiting an area, land, a resource of grass, right? Do I put limits on how many cows can graze here from a governmental standpoint to protect this area for people to use it in the future for their cows, right? You could sort of think of it like a cap and trade system, right? Or like fishing quotas, right? Massachusetts does a great job at putting quotas on fisheries, so we essentially prevent this cow situation from happening to economically important fisheries. Um, I'm just actually going to skip over this because it doesn't really we sort of already talked about. I'm not gonna I'm not gonna rehash sort of the things we talked about. So I think I'll skip those 2 slides. Now this leads us to not so much negative externalities, but positive externalities, i.e., the ecosystem services that we spent the previous hour discussing. Now, functioning ecosystems provide numerous services, both direct and indirect, that are positive impacts on both local, regional, as well as global markets, global communities, and global and local areas. So positive ecosystem services are positive externalities are really fantastic things. Now, the interesting thing about positive externalities is they typically overact with public goods, right? And as you guys probably know, a public good is something an economist would describe as things that cannot be produced profitably, since non-paying customers also receive benefits from them. So like, like a park, right? That's a public good. Roads are also another great example of them. Everyone uses them, they're public goods. And environmental services, ecosystem services, I would argue, and many people argue, are public goods as well. And so when we think about developing sustainably, when we think about how to best approach developing a new area or harvesting a new resource, we have to think about them through the lens of preserving this public good, these ecosystem services, both through our own personal views, but also through a governmental and uh, regional and local standpoint as well. Now, we can ask the question next, sort of winding down this part of the lecture, of why do we have environmental policy? And I think one of the best examples of why we have environmental policy, actually, we can take from a different area of the world, and it's actually child labor laws. Because I think child labor laws do a great job of telling us why we need to have regulations in place. Because we know we have child labor laws because if we didn't have child labor laws, we know that large corporations would exploit child labor, which is obviously really, really bad, and obviously happens still. But here in the United States, obviously, it's not a thing anymore. At least, you know, the way things used to be. So, child labor laws play a great example of why environmental policy exists. Because if we don't put policy in place, well, it won't would kind of be hard pressed to stop a situation like this, right? Sort of this cascade tragedy of the commons of our environmental resource. Um, which is I I'm always flabbergasted at people argue against uh, regulating things when we see the effects, the sort of the all positive effects of things like child labor laws and things like that. So environmental policy is a net good thing. Things need to be regulated again, or bad things happen. Now, how do policies made? Well, it really starts with scientists, right? It starts with, or well, it doesn't necessarily have to start with scientists. It could start with a human, right? It could start with you and me. I live near a, say, a coal plant, and I noticed that all my neighbors and I are developing the same type of cancer. Okay, well, if citizens are identifying problem, that leads to scientists identifying the linkage between the coal-fired power plant and a specific type of cancer. Once you identify the problem, it leads to more of a lawmaker aspect where we craft policies and eventually approve policies. Though this approving policy link is not the most effective thing, even at the local level. Um, Especially here in the United States. Eventually, that leads to the implementation of policy, and then scientists and lawmakers evaluating policy and how effective it is. And as you can notice, it's sort of this never-ending cycle, right? There's there's always going to be this need to identify environmental problems, and obviously it's for the greater good, right? The environment is super valuable, but it's also always this need to identify them, to fix them, and not only that, to evaluate them, right? We don't want to put a policy in place that we think is solving a problem and it simply is ignoring sort of a major avenue of the problem. So this is the way things typically work, right? And this has had great success. We do meh. There's clearly better countries in the world for environment. Sort of starting out of, essentially regulating the environment started with Teddy Roosevelt way back in the day, the 1920s, developing the first national parks, and the U.S. Forest Service really started back then. And then it kicked up to adding brand new national services like the National Park Services, the U.S. Forest Service, the Bureau of Land Management, the U.S. Fish and Wildlife Service, NOAA, and so on and so forth. All these government and land control agencies that have been developed to help regulate all of our things. And we can see sort of some good successes of our um, um, of our agencies, including the Clean Air and Water Act in the 70s. Really, really great um, piece of national policy crafted by many of these agencies. We also see the development of the EPA, as I've sort of already mentioned. So our policies are really controlled by large governmental things. State and local bodies typically adhere to federal standards. So there's federal standards for air pollution, water pollution, so on and so forth. But states have the capacity to exceed those standards. So, for instance, California is a great um, example of this. And I don't know how closely you guys sort of follow national politics, but California always draws the ire of oil and gas companies and car companies because they set pretty strict pollution standards in the state. You guys might famously remember Donald Trump sort of having a crusade against California because of their strict air pollution laws that were against what he wanted. So California goes above and beyond, but the vast majority of states do sort of meet the minimal standards set for waste or air or toxic pollution. At the local level, we can look at various states. So, for instance, in Texas, They have the Texas Commission on Environmental Quality, which helps monitor these things. They have their Public Utility Commission, which I'm sure you guys probably know that's not doing so well right now. That helps monitor energy consumption and stuff like that. And they also have the Texas Park and Wildlife Department that oversees a wide variety of things that affect environmental issues. Now they're supposed to meet federal standards, but again, there are states that do really good, and there are states like Texas that don't do super great. They oftentimes have poorly managed or purposely underfunded agencies to monitor the environment. It really just sort of depends on the state. So state and local policies, they do vary. And then we move up to the sort of the most chaotic way of crafting policy, and that is the global policy. And getting two nations to work together is already hard enough. And to do something like to address pollution is also really hard. I'd like to just sort of make mention that pollution isn't a local issue. When we burn something, say we have a coal-fired power plant here in Massachusetts, the wind from that coal-fired power plant goes to New Hampshire, it goes to Vermont, it goes to Rhode Island, Connecticut, New York, it goes to all the surrounding areas, right? When Chinese factories dump a bunch of, say, plastic into one of their rivers, that goes into the ocean and it affects all surrounding countries. It affects the Pacific Ocean, which affects everything around it. So pollution, I hope, is pretty clear that it's not a local issue. It is a regional issue. It is a global issue. Everything is really connected overall. So it is important to have global as well as regional things. And we do a pretty crappy job of doing things globally. For instance, one of the things that's really common, and you can sort of see this sort of awful scenario here, and we'll see this type of scenario later in the semester when we talk about waste, but we can see that here in Ghana, they're recycling e-waste from Western countries such as, France, United States, Germany, stuff like that. Again, pretty loose environmental standards here, or we can see places here where, well, I don't know where this is, but it's looks like Chinese in the back. It's hard to, I'm not, I'm not good with languages. So an Asian language, I don't know which one. In the back here, we have ivory, i.e. elephant tusks, and then we have shark fins. Again, taking an environmental commodity because there's an overall demand for it. Again, not acceptable. Not legal in most places, but again, legal in some places. So global policy does need to exist because again, we are connected overall. Now, we have what are called IGOs or intergovernmental organization. They do provide venues. In 1987, the Montreal Protocol was probably one of the, I would argue, one of the better policies that has ever been done because it really massively fixed a huge problem in the ozone layer in a relatively short amount of time, with all the countries just really coming together. Really sort of remarkable piece of policy. But there are some other ones that we could potentially sort of look at, including the Paris Climate Agreement or the Summit on Sustainable Development. But global policies are hard. As we saw with the Paris Climate Agreement, it was signed under President Obama. President Trump withdrew. President Biden hopped right back in on the first day of his office. So it's kind of a kind of a hard thing to enforce global policy because countries like to sort of pick and choose what they like. Now, sort of the last thing about this is how your own personal ethics sort of fit into this. And the reality is everyone likes to end their talks about what can you do? How would you factor in, right? You could use more sustainable stuff. But the reality is, and we'll talk about this quite a bit, the vast majority of unethical things that are done are not done by the individual, but they're done by the large corporations. And so you as the individual have a small, tiny piece of influence on all the bad things that happen out there. Again, it's really the wealthy, it's really the large corporations that are doing most of the bad stuff. And the way you sort of affect change there, it's, this is good. Obviously using less plastic is great, like this girl is doing, but the reality is the best way to sort of do it is with your wallet, i.e. boycotting businesses, buying less plastic water bottles, getting people to change their attitudes, but also voting, right? Running for office, things like that, changing things at a congressional level. That's really sort of the way to make your sort of personal ethics influence policy, influence change.
Sure.
And
You mentioned that it was the wealthy, but it's actually the consumers. Like it's like the vast majority that influence climate change.
No, it's not.
The market,
Sev-
come
sev-
on.
70% of all climate change related emissions are from 100 companies, and
And
they're
100 companies aren't owned by just 1% of people. They're owned. Are marketed publicly owned companies too. So
well, they're publicly owned by a small number of people, right? I don't own stake in ExxonMobil. Do you? Right? So large companies, again, a company like ExxonMobil, which as a company produces astronomical levels of pollution, is owned by a small number of people. And these people are really wealthy. And they have an astronomical, well, not astronomical, they have a large say on what happens at the global level and the congressional level as well, right? We've done nothing about climate change because of companies like ExxonMobil, right? Where we could have, but we don't, right? So most of what the problems we have from an environmental standpoint come from large companies. Now, are they servicing the consumer? Absolutely. But the consumer has overwhelmingly said, and it doesn't matter what problem it is, that we want this problem fixed. But again, is ignored by a company because what else are we going to do, right? We have to do these things. So again, it is a problem. You know, it is a problem of, again, large corporations are doing quite a bit, right? Our politicians don't do too much because they want donations, right? But they're not really addressing the issues that affect average everyday people, right? Climate change is not going to affect the CEO of ExxonMobil, right? It's not going to affect the shareholders of ExxonMobil. It's going to affect you and me, but not the shareholders of a large company. So that's sort of where I'm getting. I'm not trying to lump everything on large corporations. Maybe that was too stark of an argument, but again, the individual contributes so minorly to industrial levels of production. It really does. And regulating things at the local level and especially the federal and global levels is really the sort of the way we have to do things. And that's sort of the sort of the take-home message is that's the way it sort of has to go. Yeah, that's where I'd like to leave it. All right, so that is going to be it for this part. Well, actually, that's going to be it for today. So let me stop recording.